In this video, we're going to start the literal equations worksheet under the Infinite Algebra 1 tab on the KutaSoftware website. This is a free worksheet that KutaSoftware provides, and I'll leave a link in the description below. I'm going to split this worksheet up into 3 separate videos, doing 10 problems in each video. Our directions are to solve each equation for the indicated variable. In number 1, g equals 6x, and we're solving for x. So we're isolating the x. In order to do that, we're going to divide both sides by 6. When we divide by 6, we'll get g over 6 equal to x. And if you prefer to have the variable that we're solving for on the left side of the equation, you could say x is equal to g over 6. And that's the solution in number 1. In number 2, we have u equals 2x minus 2, and we're solving for x. We're going to start by adding 2 to both sides. On the left, we'll have u plus 2, and that's going to be equal to 2x on the right. Now all we have to do is divide by 2 to get that u plus 2 all over 2 is equal to x. And again, if you want to rewrite this, you can say x is equal to u plus 2 all over 2. In number 3, z equals m minus x, and we're solving for x. I'm going to do this by adding x to the other side, so I'll get z plus x equals m, and then I'm going to subtract z from both sides to get my final answer of x equal to m minus z. And remember, when you're subtracting a number, it's the same as adding the opposite or adding the negative. So you could also write this as m plus a negative z. Number 4, g equals c times a, and we're solving for a. All we have to do is divide both sides by c. Then we'll get g over c equals a. So g divided by c equals a, or you can write this as a equals g divided by c. And number 5, we're solving for x. So we're isolating that x. So we got to move the k to the other side, and we'll have u plus k equal to x. And we could rewrite this, if we wanted the x on the left, as x equals u plus k. In number 6, it's asking us to solve for x, so we're isolating that x, and we're going to do so by subtracting c. When we subtract c from each side of the equation, we'll get g minus c equal to x, and we can rewrite this as x equals g minus c. In number 7, u equals k times a. We're solving for a, so we want this out from underneath a fraction. So we're going to start by multiplying both sides by a. When we do that, we'll have a times u, or au, and that's going to be equal to a divided by a is 1, k times 1 is k. Now we just need to divide by u to isolate that a. So we'll get that a is equivalent to k divided by u. In number 8, we're solving for x. So all we have to do is divide by c, and then flip the equation. G over c equals x is the same as saying x equals g over c, since those c's will cancel out. In number 9, we have 12 times a times m equal to 4, and we're solving for a. We're going to do that by dividing by 12 and dividing by m. But we can just divide by 12 times m in one step. When we divide by 12 times m, the 12 will cancel out on the left and the m will cancel out on the left. So we'll be left with a, since 12 divided by 12 is 1, m divided by m is 1, and 1 times a is a, and that's going to be equal to 4 over 12m. However, this can be simplified down. 4 goes into 12 3 times. So we can say A equals 1 over 3 times m. So 1 over 3m is equivalent to A. And now on to number 10, which is going to be the last problem in this video. Before we do the answer to this, don't forget to like this video and subscribe to my channel. All subscriptions and likes are greatly appreciated. So we're solving for x, which means we need to isolate that x. We're going to do so by subtracting by 2c at the start. That'll leave us with a negative 3x on the left, and that's going to be equal to negative 3 minus 2c on the right. Now our last step is to divide by a negative 3. We'll have x equal to negative 3 minus 2c all over negative 3. Let's go ahead and move the negative to the top and say negative 3 minus 2c all over 3, and distribute this negative, so we'll get x equal to a positive 3 plus 2c all over 3. Since the opposite of negative 3 is 3 and the opposite of negative 2c is positive 2c. So x equals 3 plus 2c all over 3 is the solution for number 10. Continue on to the next video where we'll do numbers 11 through 20. In this video, we're continuing on with our literal equations worksheet under the Algebra 1 tab on the KutaSoftware website. I'll leave a link in the description box below so you know how to access this website. We're solving each equation for the indicated variable. So in number 11, our indicated variable is a. So in order to solve for that, we need to isolate the a. That can be done by dividing by m. When we divide by m, the m's on the left-hand side will cancel out since m divided by m is 1 and a times 1 is a, and that's going to be equal to n plus p all over m. In number 12, again, we're isolating the a. So our first step will be to multiply by b. When we multiply both sides by b, we'll get bu equal to a times k, since b divided by b is 1. Now, our last step is going to be to divide by k to get bu over k equal to a, since k divided by k is 1. However, we're going to flip this around so that a is on the left side of the equation, so it's going to be a equal to bu divided by k. And remember, the order in which you multiply doesn't matter, so you can say b times u, or you can say u times b. They're both the same. In number 13, again, we're solving for the variable a. This can be done simply by adding c to both sides. When we do that, negative c plus a positive c is 0, so a plus 0 is a, and that's going to be equal to d minus r plus c. And the order in which you add doesn't matter either, so you could say c plus d minus r, you could say negative r plus c plus d, or you could say d plus c minus r. Any of those ways is correct. In number 14, this time we're solving for the variable x, so we need to isolate x. This can be done by simply dividing both sides by m. M divided by m is 1, x times 1 is x, and then we'll have n p all over m. On to the second page, number 15, we're solving for a. We need to do this first by moving the b to the other side of the equation. When we subtract both sides by b, we'll have z minus b equals 0 plus m over a, which is m over a. Then what we need to do is multiply both sides by a to get a out from the denominator. So we'll have a times z minus b on the left-hand side, and that's going to be equal to m on the right. Except we're solving for a, not m. So now we're going to have to divide by the quantity z minus b. When we divide by z minus b divided by z minus b is 1. So we're going to be left with a on the left-hand side since a times 1 is a, and that's going to equal m all over z minus b. And remember, the fraction bar separates the numerator and denominator with parentheses, so we no longer need the parentheses in our final answer. In number 16, we're solving for x. Let's do this by moving x to the other side at the start. So we'll have negative x plus g equal to negative c plus y. Then subtract g from both sides. When we do that, we'll have negative x equal to negative c plus y plus a negative g. However, we do not want this x to be negative. We want it to be 1x, not negative 1 times x. So we're going to multiply everything by a negative 1. Negative 1 times negative x is going to be a positive x, and we're going to have to distribute this negative 1 to the negative c, the positive y, and the negative g. So now negative c, or the opposite of c, times negative 1 becomes a positive c, y becomes a negative y, and g also has its sign switched to become a positive g. So x equals c plus negative y plus g. Again, you can rewrite this in many ways, one way being x equals g plus c minus y. In number 17, g equals b minus c times a, and we're solving for a. So first we have to move this b to the other side. We're going to do this first because if we were to divide by c at the very start, we would have multiple fractions and it might get a little messy. That way we'll be left with negative ca, and then we can from there, isolate that a. So we'll have g minus b equal to negative ca. Divide both sides by a negative c, and we'll move the negative to the numerator. So we'll have negative g minus b all over c equal to a positive a, since the negative was canceled out when we divided by a negative c. When you move the negative to the numerator, you're applying it to all terms within the numerator. So this negative gets distributed to the g and the b. So this will be negative g, and then negative times the negative b would be a positive b all over c equals a. And I'm just going to rearrange this and put a on the left-hand side and say that's equal to negative g plus b all over c. Again, with addition, order doesn't matter, so you could also say b minus g or b plus a negative g all over c. In number 18, g equals c times a minus b, and again, we're solving for that a. We're going to start by adding b to both sides, just like in the last problem. So we'll have g plus b equal to c times a. Then we'll divide by c to isolate that a to get that g plus b all over c equals a. If you want to rewrite this with the a on the left-hand side of the equation, you can say a equals g plus b all over c. Remembering again that the order of addition doesn't matter, so you could also say b plus g all over c. In number 19, we're solving for x. In order to do that, we need the terms with the x's on the same side of the equation. So I'm going to move 2x to the other side. We'll have 4 equal to negative 2x plus xg. Once we're there, we'll be able to pull out an x from each of these terms. So we can say 4 equals x times negative 2 plus g. Since if we were to distribute that x, it'd be negative 2x plus xg. So we basically just reverse the distribution to pull that x out. Now remember, we're isolating that x, so we're going to divide by negative 2 plus g. This will leave us with 4 over negative 2 plus g equals x. Another way we could write this, we can go ahead and flip the equation to say x equals 4 over negative 2 plus g. And the way on the answer sheet it's written is they actually multiply by negative over negative. So they do negative 4 all over the opposite of negative 2 plus g, since this is the same as 4 over negative 2 plus g. So it'll be x equal to negative 4 all over 2 minus g. And lastly, number 20. G equals 1 plus 2a all over a, and we're solving for a. I'm going to start by multiplying both sides by a. When I do that, I'll have g times a equal to 1 plus 2a, since the a in the denominator cancels out with the a that I multiplied by. Then I'm going to subtract 2a from both sides to get my a's on the same side of the equation. So GA minus 2A equals 1. Once I do that, I'll be able to pull out an A, so kind of like reverse distribution. I'm going to pull out an A and say that A times the quantity G minus 2 equals 1. So if you can see, if I distributed the A, it would be A times G, so GA minus 2 times A. So now in order to solve for a, all I have to do is divide by that g minus 2. G minus 2 cancels out with g minus 2, and I'll have a equal to 1 over g minus 2 as the solution for number 20. As always, likes and subscriptions are greatly appreciated, so go ahead, click the like button, and also subscribe to my channel. If you have any questions, please feel free to comment below and continue on to the next video where I'll finish out the literal equations worksheet. In this video, we're finishing the literal equations worksheet. So this is the third video, so if you missed the first two, skip back a few videos and start with those. And since we're finishing out, we're doing numbers 21 through 30. We're solving for x. So number 21, we're going to start by multiplying both sides by x because we don't want x in the denominator. When we do that, we'll have xg equal to x minus c, since the x's will cancel out. X divided by x is 1. Now I'm going to move the x to the other side. So I'll have xg minus x equal to a negative c. Now we can do the opposite, or the reverse of the distribution, and pull out an x from both the xg and x term. When I do that, I'll have x times g minus 1 equals negative c. The last thing to do now is to divide by g minus 1 in order to isolate that x. Doing so, we'll get that x is equal to negative c all over g minus 1. And that's the answer for number 21. And number 22, again, we're solving for x, and we're going to start by putting both terms with x in them on the same side of the equation. So I'm going to move them both to the left. So we'll have xm minus x equals c. Now we're going to pull out an x from each of those terms. So we'll be left with x times the quantity m minus 1. And that's going to be equal to z. So you can see that if we were to redistribute that x, it would be xm minus x. Now we have to divide by m minus 1 on both sides to get that x is equal to z all over m minus 1 as the solution for number 22. In number 23, we have u plus k times a equals b times a. I'm going to start by subtracting ka from both sides so that my terms with a are on the same side of the equation. I'll have u plus 0, which is u, and that's equal to ba minus ka. I'm going to take out an a from ba and ka. So I'll have u equals a times b minus k. So if I was to redistribute that, you can see that it would be ba minus ka. So now I can divide by that whole quantity b minus k. So u over b minus k equals a. However, I'm going to put the variable that we're solving for on the left side, just like we've been doing in all the previous problems, which is an easy step. We're just going to flip the equation. So it's going to be a equals u all over b minus k. And the way it's written on your worksheet, they have it a equals negative u all over a negative b minus k, which is a equals negative u all over negative b plus k, or you can say a is equal to negative u over k minus b. Although this first equation is perfectly acceptable, I was just showing you how they got to the equation on the answer sheet so that you're aware that those terms are equivalent. In number 24, we're solving for x. Thankfully, both terms with x are already on the same side of the equation, so we can go ahead and pull it out. That'll be x times k plus y is equal to the u. Then we'll divide both sides by k plus y to get u over k plus y equals x. Now I'm going to flip the equation to get x on the left-hand side like we've been doing in all the other equations. So x will be equal to u all over k plus y. And again, on the answer key, they added a negative over a negative. So this will be x equals negative u over negative k plus y. Since a negative over a negative is the same as a positive over a positive. And then they distributed the negative below. So they said x equals negative u all over negative k minus y. So for number 24, it's simpler just to have x equal to u over k plus y. If you were looking at the answer sheet thinking you got it wrong, it was because they added unnecessary negatives, which happens sometimes when you have a computer software evaluating a problem. So just keep it simple. You don't need to add anything that's unnecessary. Let's move on to number 25. We have u equals 3b minus 2a plus 2, and we're solving for a. I'm going to move the a to the other side, so 2a is going to be added to both sides of the equation to get 2a plus u equals 3b plus 2, and I'm going to subtract u from both sides to get that 2a is equal to 3b plus 2 minus u. My next step will be to divide everything by 2. That'll leave me with a on the left-hand side, since the 2's will cancel out, and that will equal 3b plus 2 minus u all over 2. Number 26. Again, we're solving for a, so I'm going to move the a to the left-hand side. We'll have negative 9a plus z equal to negative 9 minus 3b. Going to subtract z from both sides to get that negative 9a equals negative 9 minus 3b minus c. Then I'm going to divide by a negative 9 to isolate the a. When I divide by a negative divided by a negative, remember, is positive, and all three terms in the numerator are negative, so we can rewrite them as a positive 9 plus 3b plus z all over a positive 9. So a equals 9 plus 3b plus z over 9. And number 27, we're solving for a. Immediately we can pull a out of both the terms on the right-hand side. So a gets multiplied to 4c, and it also got multiplied by the 3b. Then all we have to do is divide by 4c minus 3b. So g all over 4c minus 3b equals a. Flipping the equation around so that a is on the left-hand side, we'll get a equals g all over 4c minus 3b. And that's the answer for number 27. Again, on the answer key, they changed it around and took the opposite of both the numerator and the denominator, since a negative over a negative is a positive. So their answer on the answer key is A equals negative G all over, distributing that negative, negative 4C plus 3B, and they rewrote that bottom. But again, it's not necessary, so you can just say that A is equal to G over 4C minus 3B. And number 28, we're solving for A. So I'm going to start by adding 3 to both sides to isolate the term with the A. So we'll have negative 3A equals negative 2N plus 3P plus 3. Then I'm going to divide by a negative 3. But I don't want that negative in the denominator, so I'm going to distribute it out among the terms in the numerator. So I'll get that a positive 2N plus a negative 3P plus a negative 3 all over 3 is equal to A. And remember, the order of addition, again, doesn't matter. So if you wanted to, you could say negative 3 plus 2N minus 3P all over 3. Number 29, we're solving for X. So all we have to do is divide by 4. When we divide by 4, we'll get X equal to negative 4R plus 2D all over 4. However, this can be simplified down since 2 goes into each of these evenly. So 2 goes into negative 4, negative 2 times. 2 goes into 2D once, so that'll be left with D, and 2 goes into 4 2 times. So our final answer is X equals negative 2R plus D all over 2. And lastly, number 30. We're solving for A, so we're going to start by multiplying by KA. Whatever we do to the right, we have to do to the left. So we'll have KA times U equal to negative 2A minus 3. Then I'm going to add 2A to both sides. So we'll have 2A plus KAU, so K times A times U, equals a negative 3. Now I can take an A out of both of these terms and say A times 2 plus KU equals a negative 3. Then all I have to do is divide by a 2 plus KU. That'll leave me with A equal to negative 3 all over 2 plus KU. And again, order doesn't matter for addition, so you could also say negative 3 over KU plus 2, or negative 3 over U times K plus 2. And that wraps up our literal equations worksheet. Please remember to like this video, subscribe to my channel, and post below if you have any comments.